Right, so today I'm reading the Learning to Retrieve in-context examples for large language models. In-context examples are crucial for performing in-context learning, and the choice of the examples that you make has a significant impact on the quality of your results. So figuring out which examples you should include and which ones you shouldn't in your requests is very important, especially on models that are closed box that you can't update yourself, so black box like OpenAI and Cohere. This is work out of Microsoft through Furu's lab, and it's published where anyone can see in the LMOps repo. It was released in July of this year, so pretty recent. And what they're showing is basically the ability to train a reward-based model on the LLM feedback to evaluate your candidates. That's step one. And then step two is to do some knowledge distillation based on that feedback, based on that reward model, to train a bi-encoder that you can use just like any normal bi-encoder for dense retrieval. They experiment across a bunch of different tasks to show that this actually works. And as I mentioned, they release it so that anybody can play around with it. The work that they show, I mean, it follows the traditional, here's what ICL is, here's dense retrieval, etc. But the best piece of this paper is their visual here, where they show they start with an example pool. They figure out some amount of rank ordering on the candidates, train a reward model based on that, and then use that reward model to improve their ranker, their retrieval. Then at inference time, they can just use the retriever model to generate a candidate pool for sending to Llama, for example, although you can do this just as easily with anything else. They make an important distinction here that the reward model actually has more information during training. It has the ground truth output, so it's able to get kind of the closest possible learning to get the perfect examples, and then the hope is that during distillation you capture some of that intuition and knowledge into your retriever. They start with a retriever that is BM25 initialized and just an unsupervised version of it, and then iteratively improve the quality over time. But they do experiment with BERT as well. Then if we just jump all the way into their results, because that's what everyone cares about, we have their results after various iterations of distillation and training. And you can see basically across the board it does pretty well, but not significantly better than, like, for example, SBERT. It beats it pretty nicely across a few metrics, plus 15 relative to this on NLI versus maybe like here on CQA is equivalent or even slightly worse than E5. So there's mixed results, but clearly it is improving over the zero shot, just kind of base and random exemplars, of course. They do some further analysis on using BERT instead of BM25 and show that it doesn't actually matter too much. In both cases, 65.7 average, 65.2. Basically, it seems like it's reaching a ceiling here, regardless of where it started, which is kind of interesting to think that there is some limit to the quality that you can retrieve. But I'd be curious to see, if with a larger BERT, for example, or even more iterations, they seem to flatten out and not really improve as it gets to the third iteration. I don't know if maybe 10 iterations in, you might see something different. That's all for this one. And next time we'll probably be talking about one of these other papers that I have open.